Hello everyone. In this question, it is asked that we are required to find the integral of 1 plus sin x upon sin x times 1 plus cos x dx. Okay, so let us start this integral. Okay, this is an indefinite integral. We are given 1 plus sin x in the numerator, and in the denominator it is the product of sin x times 1 plus cos x. Okay, so it seems to me that at first glance we can't do the rationalization directly. Okay, this is not very simple substitution rationalization. Okay, let us first split this into two fractions. Okay, according to the numerator, let us split it into two fractions. So we get 1 upon sin x times 1 plus cos x dx plus we have integration of sin x divided by this denominator, right? Sin x divided by sin x times 1 plus cos x. So this sin x and this sin x will cancel each other. So we are left with 1 upon 1 plus cos x dx, right? So it seems this integral will require a trigonometric substitution. Okay, so let us use the substitution. Let u equal to tan of x by 2. Okay, so if I use this substitution, then from this relation we have tan inverse of u will be equal to x by 2, right? So now if I do derivative with respect to u on both sides, this becomes 1 upon 1 plus u square times half times dx upon du, right? We are deriving with respect to u, so this becomes dx upon du. Okay, so now on applying chain rule, in this integral we are required to substitute this dx in terms of u, right? So we have 2 upon 1 plus u square times du is equal to dx, right? Also we have this sin x and 1 plus cos x. Okay, so let us try to write this sin x in terms of tan x by 2. Okay, so we use the half angle and sub multiple angle and double angle formula. Okay, so we have sin x is 2 times tan x by 2 upon 1 plus tan square x by 2, right? This is known from trigonometric formulas. Okay, so tan x by 2 is nothing but u, so in terms of u this becomes 2u upon 1 plus u square. Okay, this is sin x. Similarly we have cos x equal to, in terms of half of tan angle, this is nothing but 1 minus tan square x by 2 upon 1 plus tan square x by 2, right? So this just becomes 1 minus u square by 1 plus u square. Okay, so these are the three relations that we will use and substitute in the above integral. Okay, this is dx, this is sin x, and this is cos x in terms of u. Okay, so let us now continue with this integral. So we have this first integral, this now becomes equal to 1 upon, we have sin x, right, in the denominator. So sin x is 2u upon 1 plus u square. So we have 2u upon 1 plus u square, right? And we have 1 plus cos x. So this is 1 plus 1 minus u square upon 1 plus u square, right? So this is the first integral. And then we have dx, right? So dx is nothing but this whole thing, 2 times 1 plus u square. So this is nothing but 2 times 1 plus u square times du. Okay, this is the first integral. And the second integral, we can just write 1 plus cos x as, we can just write it as 1 by 2 cos square x by 2, right? 1 plus cos 2x is 2 cos square x, right? So in terms of half angle, 1 plus cos x becomes 2 cos square x by 2, right? So now let us continue. So we have in the first integral, we have 2 upon, here we have 2u upon 1 plus u square times, if we take the LCM, then in the numerator it will be sum of 1 plus u square plus 1 minus u square. So this u square will cancel each other. We are left with 2 upon 1 plus u square, right? And then there is a 1 upon 1 plus u square in the denominator. Okay, so this is the first integral. In the second integral, this 2 in the denominator can be taken out, so this becomes half times integration of 1 upon cos square is sec square, right? So this becomes sec square x by 2 dx. So this is second integration is very easy. This is integration of sec square mx dx, right? Here m is half, so this is nothing but 10 mx by m. Okay, in integration, if there is a constant added to the trigonometric function, it comes in the denominator after integration, right? So integration of sec square mx dx is 10 mx by m, and in this case m is half. So this one is already done. Now let us look at this one. In this one we have 2 times 1 plus u square whole square, right? These two when multiplied together and going to the numerator, this will become 1 plus u square whole square upon 2u times 2, this will be 4u times, we have this 1 plus u square in the denominator. Okay, so this has simplified a lot. Okay, so we are left with this 1 plus u square will cancel one time, this 2 and this 4 will cancel one time, and we are left with half times, this will become 10 mx by m, m is half, so this becomes 10 of x by 2 divided by half, right? So this and this will cancel each other. So now we are left with 1 plus u square upon u, 2u. Okay, 1 plus u square upon 2u du, and this is 10 of x by 2. Okay, so if we split this again, this integral, this becomes 1 by 2u du plus u square by 2u, this becomes u by 2 du plus 10 of x by 2. So again this now becomes half times ln mod u, right? This is integration of half goes out, du by u, this is ln mod u, and this becomes half times u du, so this becomes u square by 2, right? And then we are left with 10 x by 2, right? Now we can add the constant of integration c also. So now we just need to revert back this u in terms of original substitution. Okay, so our u was 10 x by 2. Okay, so we just need to substitute that and we are completed. Okay, so this becomes half times ln mod 10 of x by 2 plus 1 by 4 u square is 10 square x by 2 plus 10 of x by 2 plus c. Okay, so this is the required integral of this 1 plus sin x upon sin x times 1 plus cos x. Okay, so you require these trigonometric substitutions and this half angle substitution. Okay, and then you need to simplify for a few steps. Okay, otherwise this is not that difficult. There are far more difficult integrals there in the syllabus. Okay, so this was relatively not that difficult. Okay, so this is the required answer. If there are doubts in any steps, you can highlight in the comments also. Otherwise this is finished. Thank you for watching.